Hello guys, this is Jiten Jain and this is our 10th signal and system lecture, and I hope you have watched all my previous lectures. And in this lecture, in last lecture we have discussed impulse response related problems, Fourier series representation of any signal, and trigonometric Fourier series and its polar form of representation of any signal. So there are mainly two types of representation in Fourier series. First is trigonometric Fourier series, and second is exponential Fourier series. We have already discussed trigonometric Fourier series. In this lecture we will see the trigonometric Fourier series related problems and exponential Fourier series and their problems, and how to convert exponential Fourier series coefficient to trigonometric Fourier series and vice versa. And we'll discuss Gibbs phenomena, Dirchlet conditions, and properties of Fourier series like time scaling, time shifting, differentiation, etc. and Parseval's power theorem we'll discuss. Okay, let's start. First, we'll discuss trigonometric Fourier series problems. One problem is a periodic rectangular signal x of t has the waveform shown in figure. Frequency of the fifth harmonic of its spectrum is. We have to find 5 f naught. Okay, fifth frequency of fifth harmonics of this signal. First of all, we have to find f naught, then we have to find 5 f naught. So what is f naught? F naught is 1 by t naught equal to, here t naught is 4 millisecond. Okay, so 1 by 4 millisecond equal to 1000 by 4 equal to 250 hertz. It is f naught, so 5 f naught will be 1250 hertz. So the next problem is a periodic input signal x of t shown in below is applied to an LTI system with frequency response h of omega equal to 1 for mod omega less than 4 pi and 0 elsewhere. Find the output. Okay, so first of all, we have to find output. So first of all, uh, we have to this is periodic signal. Okay, you should identify why we don't apply here Fourier transform, why we are applying here Fourier series. So for continuous periodic signal, Fourier series representation is used for frequency domain, and for aperiodic continuous signal we use Fourier transform. So this is periodic, so we will use Fourier series. First of all, we have to represent this in Fourier series form. Then we have to find the frequencies of and harmonics of this signal, and only frequency less than 4 pi will be passed out and other will be neglecting. So this is the transfer function of the LTI system. Okay, minus 4 pi to 4 pi will the signal frequency component will be passed, other will be neglected. We should find x of t in frequency domain. Okay, we have to find Fourier series. Here time period is 2. Okay, time period is 2 here, so t is equal to 2, so omega naught is 2 pi by t is equal to pi. So a naught will be the a naught is equal to 1 by t integration 0 to t x t dt, or area under area of the signal in one period divided by fundamental period, equal to 5. You will find 5. You have to find this area divided by the time period. So this area will be 10 divided by time period is 2, so a naught will be 5. And an formula is 2 by t integration 0 to t x of t cos omega naught n t dt. So t is 2. Okay, so x of t is 10 for 0 to 1, and 1 to 0 it's 0, so you will find it's 0. Okay, we can directly say that an will be 0. How? This contains hidden odd symmetry. If we shift here, midpoint is 5, if we subtract here DC value 5, then the signal will shifted downward, so it will look like a odd signal. So DC will be non-zero, but an odd signal has no cost terms. Okay, so cost terms will be 0. DC terms also 0, but odd symmetry is hidden na. We have to add again DC 5, so that's why a naught will be 5 and n will be 0. Bn we have to find 2 by t integration 0 to t x of t sine and omega naught t dt. Okay, so put here for 0 to 1 xt is 10. So if we put this so we will get bn. Okay, bn is also no, bn is 10 by n pi 1 minus minus 1 power n. For odd n its value is 20 by n pi, and for even its value is 0. So you know the standard form of trigonometric Fourier series. Put here a naught bn an, we will get for odd signals Pn is also 0, sorry, for even, and for odd also only non-zero. So you will find the final expression of xt like this, and so now less than 4 pi only the signal component will be passed. So this is greater than 4 pi, all these three term will be passed. 5, 20 by pi, 20 by 3 pi, this will be rejected. So first three terms will be passed through filter. Okay, next next Fourier series is exponential Fourier series or complex Fourier series. So we can derive the exponential Fourier series formula by the trigonometric Fourier series. How? If trigonometric Fourier series representation is like this, and what we have to do, we have to change this cos and sine into exponential form. As we know, cos omega is, okay, this is cos e, this is omega naught nt. Okay, so cos omega naught nt equal to e to the power j omega naught nt plus e to the power minus j omega naught nt divided by 2, means cos theta is equal to e to the power j theta plus e to the power minus j theta by 2. Similarly, sin theta equal to e to the power j theta minus e to the power minus j theta by 2j. Okay, now what we have to do, we have to separate, we have to take common from here e to the power j theta, and we have to take common from here e to the power minus j theta. Let's assume this is theta. So if you take the common terms, you will find like this. So this will be, here n is positive, that's why this will be cn. Here n is negative, that's why this will be c minus n. Okay, put here cn and here c minus n. So we have to change c minus n with cn. How we will change? First of all, put n equal to minus m, okay, or minus n equal to m, whatever you say. The limit will be like this, minus 1 to minus infinite. If n equal to minus n, n is 1, so m will be minus 1. If n is infinite, m will be minus infinite, and c minus n will be cm, and uh, and you will find like this. Okay, now again you change minus n with n. Okay, sorry, you change n with minus m. Now we have to change only m with n, then you will find like this. Now we can write it into a whole summation like this, minus infinite plus infinite cn e to the power j omega naught nt. This is the standard exponential Fourier series form. So positive and negative frequencies denotes here, in previous form trigonometric Fourier series only positive frequencies were there, but here positive as well as negative frequency both are present. Both denotes so negative frequency denotes opposite direction of rotation, that is opposite phase angle. Okay, so this is the plot of exponential Fourier series. So we have to consider this negative frequencies also. These are nothing but the mirror image of the positive frequencies, but we have to consider negative frequencies also to reproduce the original signal. Okay, so okay, how to convert exponential Fourier series to trigonometric Fourier series and vice versa. So first of all, see trigonometric Fourier series to exponential Fourier series. So here C naught and A naught formula is same, so C naught equal to A naught, and Cn, how to find Cn by An and Bn? So Cn equal to An minus Jbn by 2. You can derive it, but no need to derive here. It is very simple. So Cn will be equal, Cn is equal to 1 by t integration 0 to t gt e to power minus j and omega naught t dt. Remember this. And C minus n equal to An plus Jbn by 2 equal to 1 by t integration 0 to t g of t e to power j omega naught n t dt. Okay. So only remember this formula. You have to replace n by minus n. So here also minus n. You will get it. Okay. So you have to remember this formula. This is the basic formula, and if you have to convert one form to another, so Cn equal to An minus Jbn by 2 and C minus n equal to An plus Jbn by 2. If you want to convert exponential Fourier series to trigonometric Fourier series, so A naught equal to C naught, An equal to Cn plus C minus n, or Bn equal to C minus n minus Cn. Okay. Okay. So one problem is obtain the exponential Fourier series representation of periodic signal shown, hence find trigonometric Fourier series. First of all, we have to find exponential Fourier series, then we have to convert it into trigonometric Fourier series. So here fundamental period is t equal to 1, and so omega naught will be 2 pi by t equal to 2 pi. So we can write the equation of x of t equal to t for 0 to 1. Okay, this for one period its value is t. So first of all, you have to find exponential Fourier series coefficient. So Cn equal to 1 by t integration 0 to t x of t e to power minus j omega naught n t dt. If you once you calculate Cn, you don't need to calculate C minus n. Okay, so you put here t's value to 1 and omega naught is 2 pi and okay. Now we will find you have to integrate this by product of two functions. You can integrate it. Okay, so what you will get, Cn is j by 2 pi n, so C minus n will be, or replace n by minus n. C naught, what will be C naught? C naught, you can find C naught by the formula 1 by t integration 0 to t x of 0 to t x of t dt, or you can directly find the area of the signal over one period and divide by the fundamental period. So area, this is triangle, the area will be 1 by 2 integration 1 by 2 into 1 into 1, so you will find 1 by 2 divided by period 1, so C naught will be 1 by 2. Yeah, and magnitude, okay, you can find mod Cn as well as angle of Cn. Okay, angle of Cn will be pi by 2 for positive and minus pi by 2 for negative and okay, you can find it. Okay, then you can draw the Cn plot, for magnitude as well as phase plot, both will be different. Mod Cn is like this because, okay, you can't think once we find Cn, so put n equal to 0, you can find C naught. It's not like that, because C naught is different and Cn is uh, Cn is true only for the n from 1 to 3 4 like this, and minus 1 minus, except 0, Cn is true for all value. So mod Cn is 1 by 2 pi n. So at C naught 1 by 2 we have calculated different separately, and put n equal to 1 2 like this, you will get a mirror image in the negative side. Angle of Cn we have already calculated here, pi by 2 for positive n, minus pi by 2 for negative n. Okay, you can draw here. So if now we have to find trigonometric Fourier series for exponential Fourier series. So n, we know the formula, n equal to c minus n plus cn, and put here value, an will be 0. Why? Because this is a odd signal. Not odd, but n is the 0. Okay, let's see this is odd or not. We can see. Okay, this contains odd or hidden odd symmetry. Okay, the DC value will be non-zero. Okay, so we can find bn also. So jbn, okay, their formula was wrong, sorry, I forget to tell you that jbn equal to c minus n minus cn. Okay, jbn equal to c minus n minus cn. So you can find bn from that. So you can, okay, for, if you want to plot, if you want to plot the trigonometric Fourier series, you have to derive the polar form. Okay, so you know polar form, tn coefficient, mod dn equal to under root an square plus bn square, and angle of dn equal to tan inverse minus bn by an. You will find like this. Okay, okay, if you want to draw this in negative frequency, then you have to take half magnitude. Okay, for the periodic signal x of t is given. Okay, find the exponential Fourier series coefficient. You have to find cn and c naught. Okay, so here first of all you have to find fundamental frequency, means omega naught. How will find? Here omega naught is okay, okay, here omega naught is 2 pi by 3, here omega naught is 5 pi by 3. Sorry, this is omega, this frequency. We have to find fundamental frequency. So take GCD of this on this. You will find 5 by pi by 3. Omega naught will be pi by 3. Now what we have to do? We have to represent it into the exponential Fourier series. So the standard form is like this. So you can write it 2 plus cos this na, you can cos theta is equal to e to power j theta plus e to power minus j theta by 2. You have to find exponential for it, that's why you have to convert it into the exponential form. Okay, similarly you convert it into exponential. Now you see omega naught is pi by 3, so here n is 2. So okay, so e to the power j n omega naught t, so n is 2, so its coefficient will be c2. So c2 is equal to 1 by 2, and c minus 2 is also equal to 1 by 2. C naught is 2, and this is c5, so c5 is 4 by 2j. So c5 is 4 by 2j means minus 2j, and c minus 5 is minus 4 by 2j means plus 2j. Okay, this is simple. And next problem is the Fourier series representation of periodic signal is given. If one of the component is a cos 3 pi t, find a. We have to find a here. Okay, type of question is different. First of all, here given that omega naught is pi, by form we can say that omega naught is pi. So we have to find third harmonic this signal. So so put here n equal to 3, you will find a. So put okay, okay, a cos 3 pi t, no, sorry, not just if you put n equal to 3 you will not get, because this is cos, this is exponential Fourier series. You have to find trigonometric Fourier series from this. So what we have to do, we have to calculate an is c minus n plus cn. Okay, c minus n plus cn, so c3 plus c minus 3. So cn is given, put n equal to 3, and okay, in both c minus n is also put n equal to 3, sorry, here minus 3, put n equal to 3 and minus 3, you will find like this, and add to them to get an. You will get an. Okay, so this will be a. Okay, this will be, because here n equal to 3 now, n equal to 3, that's why here n equal to 3. Means cos function correspond to an, sine function correspond to bn. If instead of cos in question we have given sine function, you have to calculate bn. Okay, so consider the two-sided signal spectrum shown in figure for signal x of t. Find x of f. Sorry, okay, 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 okay. So for signal given, you have to find x of t. Means you have to represent it into the Fourier series form. So plot is given, means spectrum is given, magnitude and phase. So how will calculate? Means from here you can tell that fundamental frequency. What is fundamental frequency? means GCD of 12, 20, 28 will be omega naught or f naught. Sorry, here hertz is given. So f naught equal to GCD of 12, 20, 20, 28. So 4 hertz. Okay. So polar form you can write in polar form. D naught is 2. Put here D naught is 2. And what is Dn? It is wrong. It limit is n equal to 1 to infinite. Okay. So take care of it. So what is Dn? So f naught is 4 na. So 12, this is 12. 12 means third harmonic. So D3 is 3. Okay, so in both side 3 3, so you have to take 1 plus infinity. That's why limit is only for positive sides, so that's why you have to double it. For two sided spectrum you want to represent into the polar form, you have to double it. So 3 into 2 6. Okay, put omega naught 12 means omega naught into n 12, and sorry, f naught into n is 12. You have to take 2 pi different separately, and theta n is 180 here. For 12 phase is 180, that's why I taken here 180. Again for uh, okay, again for 20 again you have to double. Here 4 is given, you have to double. Okay, for 28 you have to double, you will write 2. You can represent. Okay. Okay, if you want to plot the polar form in two-sided spectrum, so one thing is that here n is 1 to infinity, you have to remember this. One thing is that you have, for plotting magnitude plot, you have to half the magnitude, as well as if you want to draw phase diagram in positive side, you will draw the same phase, but in negative side you have to take negative of that phase. So convergence of Fourier series. Convergence of Fourier series is possible only when a naught, a n, b n, c naught in all coefficients should be finite. Okay. Next is Gibbs phenomena. What is Gibbs phenomena? If you, okay, I already told you any periodic signal can be represented in terms of sinusoids. Okay, you can represent it sinusoidal. That's why Fourier series comes into existence. So if you suppose this is a square waveform, and you, this will be like, sum of different harmonics of sinusoids. So there will, irrespective of the number of harmonics we are adding here, okay, irrespective of the number of harmonics of we are adding here, always at the point of discontinuity, always at the point of discontinuity, 9% of overshoot is observed. 9% overshoot is observed here always. That is Gibbs phenomenon. Okay. Okay, means here what we assume that we approximate it like same sinusoid, means truncation. We assume here truncation. So truncation in time correspond to ripples in frequency domain. Okay, truncation in time, if you approximate in time domain, you are taking assumption in time domain, there will be error. The correspond frequency domain will have ripples. Okay. Next important condition in Dirchlet conditions. Um, it states that any periodic signal will have Fourier series only when these three conditions will be satisfied. Means, okay, any signal to be to have Fourier series form should be satisfy these three conditions. First is x of t should be absolutely integrable over one period. Integration 0 to t mod x t dt should be less than infinite. And second condition means x of t should be absolutely integrable. Second condition is x of t should have finite number of maxima and minima, not more, not infinite. Okay, should have finite number of maxima and minima. Third is x of t should have number of, means the number of discontinuities in x of t must be finite. Okay, not infinite. Number of discontinuities should be infinite, should be finite, sorry. Suppose first example is the first signal is 1 by t for 0 to 1. So fundamental period is 1, it is repeating or okay, So this signal is like this. At t equal to 0, its magnitude is infinite. So this, I already told you that the signal's first condition was the signal should be absolutely integrable. So its magnitude is infinite, so absolutely its integration will be infinite. So that's why it is not absolutely integrable. That's why it cannot be represented in Fourier series form. It cannot have Fourier series representation. Next signal is like this, y of t. So this is absolutely integrable because magnitude is finite, and second it has finite number of maxima minima, and third is it has finite number of discontinuity. Okay, that's why the signal is um, can have Fourier series. Okay, now here see, this signal cannot have Fourier series. Why? Because it contains infinite number of discontinuities. Okay, that's why it cannot have Fourier series representation. This signal has also infinite magnitude. That's why it cannot be, okay, not valid. Fourier series is not valid for that signal. This signal have infinite number of maxima and minima. That's why this signal cannot have a Fourier series form. So properties of Fourier series, few properties are there. First is linearity. If x1t is one signal has a Fourier series coefficient Cn, and x2 has Fourier series coefficient Dn. Okay, one form. Both are in exponential Fourier series. Okay, don't confuse like with polar form. Both are exponential Fourier series coefficient. So alpha into x1 plus beta into x2, this composite signal will have alpha into Cn plus beta into Dn Fourier series coefficient. Okay, this is called linearity property. Second property of Fourier series is time shifting. If x of t have Fourier series coefficient Cn, so x of t minus t naught will have Fourier series coefficient e to the power minus j omega naught and t naught into Cn. Okay, so shifting in time domain will correspond to multiplication of exponential in another domain. Okay, in frequency domain, means with same sign, here minus t naught, here also minus t naught. Okay, e to power minus j omega naught n into t naught. When we okay, already told you that property, and this uh, means shifting in time domain will correspond to phase change in frequency domain and will be proportional to n into omega naught. Okay, so what is, okay, third property is frequency shifting. If you shift, means if x of t have Cn Fourier series coefficient, so if you multiply, if you shift in frequency domain Cn minus m, then correspond to multiplication of exponential term in time domain with opposite sign, it was j omega naught m t into x of t, Cn minus m. Okay, here minus m, here plus m. Okay, so time shifting sign is same, in frequency shifting sign is different, so remember this. Okay, okay, so here what, okay, and one point you should notice that in time shifting, uh, when you find frequency coefficient, Fourier series coefficient, the variable term was n, but here in frequency shifting variable term is t na, you should uh, take care of it. So remember, shifting in one domain correspond to multiplication by exponential term in another domain. So one problem is there, the Fourier series coefficient of signal x of t shown in figure are given. Find Fourier series coefficient of y of t, f of t, g of t. Means this signal Fourier series coefficients are given. We have to find Fourier series coefficient of this derived signal. So how relate, if okay, we have to write this all signal in terms of x of t, we can find Fourier series coefficient using the properties we have studied. So y of t is given like this. So okay, x of t is given like this. X of t time period is 2, omega naught will be pi. You can write y of t in terms of x of t. You can write what, if you shift this signal by right by amount of 1, you will get y of t. So y of t is nothing but x of t minus 1. So here we will use time shifting property. X of t has Cn. Okay, so x of t minus 1 will have e to the power minus j omega naught n. Here n value is e to the power minus j omega naught n into t naught. T naught value is 1. So into Cn na, equal to dn. So omega naught is pi. So dn equal to e to the power minus j pi n is equal to minus 1 to the power n Cn. So if you want to find d naught, put n equal to 0. You will get d naught equal to 1 by pi, because c naught is given na, in question. If you want to find a d1, put here, you will get d1. c1 is given. Okay, dn for e1 for n e1, dn will be like this, because okay, because for e1 and minus 1 to the power n will be 1, so dn will be cn. Okay, okay, you should see first question. C naught is given, c1 is given, cn is given for only n e1. For other c2 c3 c5 c7 other odd term will be 0. Here 0, not given means 0. Okay, next is ft. You can write ft in terms of x of t, means this is nothing but xt. Okay, and this is what, this is minus yt na, this is minus. If you take negative of this, you will get this lower terms. So x of t plus minus yt, you will get f of t. Okay, x of t, f of t plus equal to x of t minus y of t. So using linearity property, suppose it has fn, Fourier series coefficient, it has cn, it will have it has dn. So cn minus dn will be equal to fn. Put here n equal to 0, you will find f naught. Put n equal to 1, then for n e1 you will find fn. Put another signal is g of t. This is nothing but, this is x of t na, and this is y of t. So g of t equal to x of t plus y of t. Using linearity property you will find this. Next problem is, if you have any doubt related to problems, you can write into the comment box, then I can help you. So next problem is, let x of t be a periodic signal with period t and Fourier series coefficient Cn. Okay, so let y of t is given, y of t in terms of x of t is given, the Fourier series coefficient of y of t we have to find. If dn equal to 0, okay, not for Fourier series coefficient of y of t is given, dn equal to 0 for all odd n, then t naught can be. Okay, so we have to find first dn equal, we have to take dn equal to 0. So find dn, means Fourier series coefficient of y of t will be equal to dn equal to this is time shifting property, so e to the power minus j omega naught and t naught cn, or here plus t naught, so take plus t naught. So put here okay, take common cn. Okay, you will be in form, it will be in form 2cn cos omega naught and t naught, so it is 0. So it is equal to 0. So cos theta is equal to 0 means theta equal to 2n plus 1 pi by 2. Here n is already be taken, so take m. So 2m plus 1 pi by 2. Theta equal to 2m plus 1 pi by 2. So it is wrong, so don't see it. Okay, so theta equal to 2m plus 1 pi by 2. So only here what the wrong is, this n you should take 2m plus 1, 2m plus 1. Put m equal to 0, minimum value is m equal to 0, so you will get 1 here, 1 into pi by 2. put n equal to 1 here. Okay, so omega naught t naught equal to pi by 2, so 2 pi f naught, 2 pi by t naught equal, sorry, 2 pi f naught t naught equal to pi by 2, get cancel pi pi, so t naught equal to 1 by 4 f naught, or we can say t naught equal to t by 4. Okay, by you can solve it by your own. Next property is time scaling. So signal x of t is has Fourier series coefficient Cn with time period t and fundamental frequency omega naught, and x of alpha t will have same Fourier series coefficient Cn. Only difference will be time period will be reduced by alpha, t by alpha, and fundamental frequency will be uh, increased, alpha omega naught. Means compression in time domain will give you expansion in frequency domain. Okay, time compressing by alpha changes frequency omega naught to alpha omega naught. Okay, means if you x of alpha t will have same Fourier series coefficient, only fundamental frequency and time period will be changes, so t becomes t by alpha and omega naught becomes alpha omega naught. You can prove it here. X of t is like in this form, put t equal to alpha t, so alpha omega naught frequency is fundamental frequency omega naught dash equal to alpha omega naught, so t dash will be t by alpha. Suppose one example is given, x of t is given Cn. X of t has Fourier series coefficient Cn here, so 1 minute. So Cn, okay, with fundamental frequency omega naught, we have to find x of 2t. So x of 2t will have same fundamental, sorry, same Fourier series coefficient, but the frequency will be 2 omega naught. So means here the gaping between the samples will be 2 omega naught. Okay, so compression in time domain is expansion in frequency domain. So next property is differentiation in time. X of t has Fourier series coefficient Cn, then d by dt xt will have j omega naught n Cn Fourier series coefficient j omega naught n. Okay, okay, so if you differentiate k times, so Fourier series coefficient will be j omega naught n whole power k Cn. By using these properties you can solve all problems with very less time. Okay, by using derivative method, find Fourier series coefficient of the signal shown in figure. You should be practiced with these properties. Okay, you have to find Fourier series coefficient of this signal. How will find? It is very easy. This signal is given, you have to differentiate, you have to derive this, you have to derive from this to impulse form, because using impulse signal the finding the Fourier series coefficient is very easy compared to other signal. So this is combination of step signal. You can, if you derive it, you will get impulse train like this. Okay, I hope you will get this by your own. If you don't, please ask me. Okay, so y of t equal to d by dt xt, this is y of t, so we'll have tn equal to j omega naught n Cn. Cn will be dn by j omega naught n. So we have to find Cn actually. Cn is Fourier series coefficient of this na, and dn is Fourier series coefficient of this. We can find dn easily, we have to find Cn at last. First of all we have to find dn. I will find 1 by t integration 0 to t y of t e to power minus j omega naught n t dt. Okay, so put here y of t del of t plus alpha, actually you should take minus t by 2 plus t by 2. Okay, so you will get like this. Then if we solve it, you will get this sine term. Then dn is like this, 2j by t sine omega naught n d by 2. Oh sorry, this is alpha by 2. Okay, So Cn equal to dn by j omega naught n. You can take d, okay, this is d, means what d, this d by 2. You can find Cn, because Cn equal to dn by j omega naught n, using differentiation property. You will find answer like this. Next question is this: what, again using differentiation property, you have to find Fourier series coefficient. First of all, this is combination of ramp signal. If you differentiate it, you will get combination of step signal. Then if you again differentiate it, you will get impulse signals. Then you can find Fourier series coefficient. You have to differentiate twice. Okay, you will find this. A periodic signal has the Fourier series representation of this. Without finding x of t, find the Fourier series representation of Tn and omega naught. Okay, we will solve this problem in next lecture. You see in detail in this problem once. What you have to do, you have given this, you have to find Fourier series coefficient. First, if you will differentiate it, this is nothing but Vm by pi r of t, then minus 2 r of t, sorry, Vm by pi r of t plus pi minus 2 v by pi r of t plus v r of t minus pi. If you differentiate it, you will get u of t terms, then you will get t del terms, impulse terms, then you can find easily. Okay, if you have any doubt related to this lecture, please ask me. Please means uh, tell me, write into the comment box. And if you like this lecture, please subscribe for the next lectures. Okay, thank you.